So your homework was to determine Okay, guys, has everybody exchanged their paper? All right, so ammonia is in H3. The way that I taught you to do this, starting with the previous unit, was to first find the electron dot formulas. Nitrogen has 5 electron dots. That's the valence electrons. It would look like this. Hydrogen only has 1 dot and only needs 2. Ammonia or nitrogen will need 8. And the way you get all of them to work together is you share these electrons in this way. It doesn't have to look as pretty as that. I know where they go. You don't have to know where they go. But you do have to share the lone single electrons around the nitrogen with the hydrogen, so that the nitrogen now has a total of 8 valence electrons. It meets that octet rule. From this, then, you've got to have a Lewis dot formula where you squeeze the electrons in between the element symbols. Oops, that should be a hydrogen. And you got a lone pair of electrons up here. From that, then you can get a three-dimensional shape. We start with the electron pair shape, where nitrogen is the middle, and I have 4 sets of electrons around this central atom. And the sets of electrons around the central atom are what's going to tell you what the shape of this electron pair shape is going to be. So we have 4 pairs, okay, and 4 pairs will give you a tetrahedral. A tetrahedral has a leg that goes up, a leg or arm that goes more than 90 degrees but less than 120 out to one side. You've got a leg or arm that comes out toward you, and a leg or arm that swings back behind the paper. So here's those 4 electron sets, okay? And if we were to name this, I didn't ask you to name it, but just so we're to reinforce, this is a tetrahedral electron pair shape. Okay, this is a Lewis dot formula. These are electron dot formulas. And we end up with what's we call the sharing arrangement. All right, from the electron pair shape then, we're going to take and put hydrogen atoms on the number of pairs of electrons that are being shared. So we're not going to put hydrogens on 1 pair because that's a lone pair, but we're going to put hydrogens on 1, 2, 3 pairs here around this structure. It really doesn't matter where. It's a little bit easier if I do it like this. I mean, a little bit easier to see the result when I do it like this. It's not that it's necessary there. Okay, so there's the modified. It is still tetrahedral. You don't have to name it. There's no points for naming it at this point. That was all in the last unit, but this is a tetrahedral modified electron pair shape. And then finally, to get the molecular shape, we're going to draw the exact same drawing. Now, I told you on the last test somebody was going to fail to do this last step, and they did. And I hate that because this is how you get all the points. But you got to draw exactly the same drawing without the lone pair. So you can't spread this out 120 degrees. It's not flat. It forms this trigonal pyramidal shape. So if you don't draw it exactly the same without the lone pair, then you're going to lose the points on the last step in the process. Okay, so this now is a trigonal pyramidal molecular shape. Okay? Now, in order to know whether your molecule is polar or not, you've got to meet two conditions. The first condition is that we have an uneven, or you can list it either one first, an uneven arrangement of bonds. Well, the molecular shape has an uneven arrangement. It's uneven because we removed the lone pair. Okay, so that's kind of like the shortcut way of understanding when you have an uneven arrangement. If you have to remove a lone pair, you're going to have an uneven arrangement. Okay? If you have to remove a lone pair, you're going to have an uneven arrangement. Now, the uneven arrangement is actually because there's an uneven angle between all the bonds. So between here and here is about 109.5 degrees. But across the top, there's way more than that. Okay? So there's sort of an empty space around the top of this, and that makes it uneven. So then the other thing you have to figure out to have a polar molecule is you have to have polar bonds. Okay? Now, last week I said that we are simplifying our understanding of how you get a polar molecule to the point, almost to the point of absurdity. Okay? So once you really, further in college, if you take organic chemistry or college level chemistry, you'll have a lot more information and a lot more understanding, hopefully, about polarity. This is like we're just kind of beginning to set you up for that. Okay? There's a great deal more to understanding polarity of molecules. Wait, I need to see that before you put it away. Okay? Okay. So we're trying to do a really, really simple method for you to predict polarity in really, really simple molecules. So you got to meet both conditions: uneven arrangement of bonds and polar bonds. Now, to find if you have a polar bond or not, we've got to look at the periodic table with electronegativities. Nitrogen has an electronegativity of 3.04. Hydrogen has an electronegativity of 2.1. We want to find the difference between the two. And the word difference is a math term for subtraction, basically. It indicates you're supposed to do subtraction. So the electronegativity for nitrogen is, let's see, 3.04. Yep. The electronegativity for hydrogen is 2.1. Okay, and so when we subtract here, we get an electronegativity difference between a nitrogen to hydrogen bond that is equal to 0.94. Just to be consistent, when we were in Unit 1, we learned to round properly, and we said that when we have an empty slot, we've got to round off that last digit. Okay? And so the electronegativity difference we actually want to use or consider is 0.9. Okay? There are no units of electronegativity. This is an assigned number based on behavior. At least I've never heard of any units. There might be units out there that just haven't been brought to my attention. But at least as my understanding, there are no units. And so we needed electronegativity to have a polar bond. They have an electronegativity difference between 0.5 and 1.5. Okay? So is this between 0.5 and 1.5? Yeah, it is. So we have an uneven arrangement of bonds. We have a difference in electronegativity between 0.5 and 1.5. So we met the conditions to have a polar molecule. And our claim then is that NH3, which is ammonia, is a polar bond. Is a polar molecule. Justification is what we've shown up here. It has an uneven arrangement. And polar bonds. Okay? I'm just emphasizing claim and justification because that's kind of important for you to understand in the sciences. Okay, so here's all the work you have to do. You have to show me how you got the shape of the molecule. And the way we've been taught to do that is to start with a sharing arrangement. I'm going to give you a point for each of the electron dot formulas. There are 4 of those. And then I'm going to give you 3 points for showing me how we share electrons. And that's a total of 7 points for just this part right here. Okay? Then you're going to squeeze the electron dots in between the element symbols. And you basically squeeze 1, 2, 3 sets. So for the Lewis dot formula, I'm going to give you 3 points. Okay? For the tetrahedral electron pair shape, you had to draw the tetrahedral arrangement correctly and put electron dots on there and the nitrogen in the middle. So let's say there's 4 legs here, a set of dots on each one, that'd be 8, and I'll give it 9 points here for the electron dot shape, electron pair shape. Okay? Then for the tetrahedral modified electron pair shape, all you had to do was replace 3 sets of electron dots and draw exactly the same shape. I'm going to give you a point for the shape, and I'm going to give you 3 points for putting the hydrogens on 3 of those arms. That's a total of 4 points for this. Here, all you had to do is redraw exactly the same shape. I'll give you a point for drawing exactly the same shape, and a point for removing the electron pair at the top. That's 2 points for this. Okay? You're going to have to determine the electronegativity difference. So you had to, if you're going to show all your work, you've got to show the electronegativity for nitrogen, that's a point. Show the electronegativity for hydrogen, that's a point. And subtract properly, that's a point. And round off properly, that's a point. So that's a total of 4 points for this. Okay? Alright, that's enough to make a claim. Somewhere in there, you've got to say why it is, because I think the question was, well, no, I just said determine. I didn't say explain how you got it. I said show all your work. So you have to say then it is a polar molecule. So all you really have to do is make the correct claim. That'll just be 1 point for making the correct claim here. So let's see, that'd be 7, 3 is 10, 9 is 19, 4 is 23, 25, and then I guess 30, isn't it?